Assalamualaikum warahmatullahi ta'ala wabarakatuh and very good morning. My name is Dr. Faizon bin Abdullah. I'm currently a senior lecturer at the Faculty of Science, University Technology, Malaysia. Today, I would like to demonstrate to you how gravimetric determination of nickel can be attempted. I would like to explain the basic principle first. Dimethylglyoxime or DMGH is an organic precipitant principally used to determine nickel. The MgH selectively reacts with nickel at a controlled pH of between 5 and 11. The formation of chelates between the nickel-2 ion and DMGH can be written as follows. DMGH is almost insoluble in water and is aided in the form of a 1% solution in 90% ethanol. 1 milliliter of this solution is sufficient for the precipitation of 0.0025 gram of nickel. The precipitate form is so bulky that the presence of a very small amount of nickel can be handled conveniently. Nickel is normally precipitated by adding the MgH reagent to a hot acidic solution of nickel-2 ion, which is then made basic by addition of ammonia. Only a slight excess of the reagent should be used since the MgH is not very soluble in water or in very dilute ethanol and may precipitate if very large excess is added. Now, I would like to show you the apparatus as well as the chemicals required for performing this analysis. As you can see, we require quite a lot of things on our table now. First, we require the use of concentrated nitric acid. Here it is, concentrated nitric acid. Then we require the use of DMG in alcohol. We also require the use of urea, ammonium hydroxide in dilute form, nickel sample solution, litmus papers, several volumetric flasks, a thermometer, sintered glass crucibles, a desiccator with silica in it, beakers and the stirrer, pipette filling and the pipette itself, as well as the washing bottles. Now, the first step of doing this experiment is by pipetting 50 ml of nickel sample solution into a 100 ml volumetric flask. Dilute to the mark with distilled water, followed by mixing the mixture thoroughly. So this is how we are going to do it. Now, I am going to pipette 50 ml of nickel sample solution. You have to measure accurately, focus on the meniscus level so that you get the accurate amount of volume that you require. It can be a little bit tricky somehow, but you need to get to the meniscus. Well, you can see it can be a little bit difficult to get the volume, but now I get it. So I'm going to transfer this 50 milliliter of nickel sample solution that I've pipetted into the calibrated volumetric flask. 100 milliliter calibrated volumetric flask to be precise. Upon completion of transferring the sample into the volumetric flask, the next step is to dilute it using distilled water up to the 100 mark for the volumetric flask. You have to do it very carefully, and the final step, perhaps you may want to use dropper to drop little amount of distilled water to the volumetric flask so that you can get accurate representation. Finally. Now, what I'm going to do is I'm going to mix it thoroughly by flipping the volumetric flask like this up and down for several times to ensure homogeneity of the solution. Now, what I'm going to do is I'm going to transfer this solution into a beaker. And from this beaker, I am going to pipette 25 milliliter of each of the solution into 3 different 250 milliliter beakers for the subsequent steps. Now, I'm going to demonstrate to you how I'm going to transfer 25 milliliter of the solution into the beakers. Look carefully, accuracy is very important, especially when you look at the measurement. Then, add 100 milliliter of distilled water to each of the beaker, followed by heating it to approximately 80 degrees centigrade. You have to check the temperature to make sure that the solution has reached that particular temperature by using a thermometer. And when you do so, please make sure that you rinse the thermometer to ensure that you are not going to move out any solute from the solution that would affect the accuracy of the determination in subsequent steps. So this step is very important for you to follow. Upon completion, the step can be repeated to the remaining 2 beakers that contain the sample solutions. Now, I'm checking the solution to make sure that 80 degrees centigrade has been achieved. It appears that the solution has reached that temperature that we wanted. Now, the next step, I'm going to add 10 milliliter of DMG solution into the solution while maintaining at high temperature. Before the DMG can be transferred into the solution, the DMG must be measured first to ensure the accuracy of the amount. Now, after I'm getting the amount that I'm wanted, I'm transferring 10 ml of DMG into the beaker, followed by stirring. Now you can see the color has changed. Next, I'm going to check if the mixture has turned into acidic form. I'm going to use a litmus paper to do that. If the solution is not yet acidic, I'm going to add concentrated nitric acid dropwise until it becomes so. This is how I'm going to do that. Well, as you can see here, after checking the solution with the litmus paper, it appears that the solution is not yet acidic. So it is imperative for me now to add the concentrated nitric acid by dropwise. Where is my concentrated nitric acid? Here it is. Now I'm going to add dropwise of this nitric acid into the beaker. I'm going to stir it for a while, and then I'm going to check whether the pH has turned acidic. Well, using this litmus paper, it can be seen that the solution has turned into acidic condition. That is fantastic. The next step is to add 3 grams of urea into the beaker, followed by stirring again. And then the mixture can be boiled for 2 to 3 minutes and cooled to room temperature for the subsequent process. Now, here how it can be done. Let me show you guys. After adding the urea and stirring, followed by heating it to about 2 to 3 minutes, now it's time for us to cool it down. You have to repeat the step for the remaining 2 beakers that contain the sample solution. Now, I'm going to check my crucibles. It is important that crucibles to be used must be washed with oxalic acid and rinsed using distilled water and let to dry in an oven at approximately 1 degree Celsius. Well, I have my sintered crucibles in this oven already. Now, what I'm going to do is I'm going to remove them and place in a desiccator, close it, and bring the crucible for weighing. Now, this is how I'm going to remove it. Be careful, it's very hot. Yeah, now let's go. Next step is to weigh the crucible, and I'm going to weigh each and every crucible using this weighing balance, one by one. So make sure that your weighing balance is actually working accordingly. It's set to 0. Now I'm removing the first crucible from the desiccator, and I'm going to transfer that on the weighing balance. Careful, make sure that you place the crucible at the center of the weighing balance and then close the lid. Now wait until the number becomes constant. Wait, look at the number, right? So it's still moving. Wait until it stops. Okay, now you can see that it is stopping, and the weight of the first crucible is 5.129 grams. Right, I'm going to record that and transfer back the first crucible into the desiccator, followed by the second one. Same procedure. Now let us wait for the number to become constant. Yes, the weight of this second crucible is 5.079 grams. Right, so now I'm removing back the crucible into the desiccator, followed by weighing the third crucible. Careful. Now I'm moving up the third crucible into the weighing balance. Okay, so the weight is 5.0977 grams. Okay, now we have done measuring the weight of these 3 crucibles. So I'm going to bring the crucible back into the desiccator for the subsequent step. Now, the next step is to add diluted ammonium hydroxide into the cool samples. I'm going to add this ammonium hydroxide dropwise until no further formation of red coloration upon mixing with the solution mixture. I'm going to do this for all the 3 replicates. This is how I'm going to do it, and please make sure that you stir them well. Now, I'm turning on this filtration unit. I'm going to filter the each of the replicate through the weight sintered crucible using the suction filtration. I'm going to run some distilled water through the crucible to wash the precipitate in order not to miss any solute from the calculation later on. So this is very important to ensure that you have as accurate result as possible. Phew, done with the filtration. Now, let us hope that my microwave works perfectly. So the next step is we have to dry the crucible in this microwave using medium power for about 4 minutes before cooling it down in a desiccator and followed by weighing again. We have to repeat this process twice or more until we have reached the constant weight. So please bear aware that handle hot crucible with tongs or towels. Place crucible in desiccators between weighing. So these steps are very important. After the crucibles have reached or cooled to room temperature, now it's time for us to measure the weight. Right, I'm going to measure the weight for every single crucible in this desiccator. I'm going to measure it and then record the reading. I have to repeat this process, the drying and weighing process, at least 2 or 3 times until the constant weight can be achieved. After getting all the correct values, now it's time for us to do some calculation to determine the concentration of nickel in these specimens. Let's do that.